So far in working with logarithms, all we've really done was to convert to and from the exponential form. How do we work with a logarithm as such? Is there some equivalent to something like the distributive property? And the answer to that is, well, kind of. Every property of exponents has an equivalent property of logarithms. So now we're going to take our well-known properties of exponents and translate them into properties for logarithms. To do that, we're going to use some symbols. So we're going to fix a base. And what we mean by that is it's a positive number and it's not 1. So it's one of the numbers that we might have as the base in an exponential function or a logarithm. And then we'll let m and n represent any two numbers, and x and y be what we get when we take b to that power. So we have x is b to the m, which means the log base b of x is m. We have y is b to the n, so that means the log base b of y is n. Now, one of our rules for exponents tells us what happens when we multiply together two powers of the same base. If we multiply together our x and y, that's b to the m times b to the n. When we multiply together two powers of the same base, we add together the exponents. So that means if we take the log base b of x times y, that's going to be m plus n. In other words, the log base b of x times y is the log base b of x plus the log base b of y. The way that we describe this in words is the log turns multiplication into addition. So if we're multiplying things together and then taking the log, we can instead take the log and then add. That's the equivalent of our rule of exponents for when we multiply. What about it when we divide? If we take x divided by y, well, that's b to the m divided by b to the n, which is b to the m minus n. In log terms, the log base b of x over y is going to just be m minus n, or in other words, the log base b of x over y is the log of x minus the log of y. The way we describe that in words is the log turns division into subtraction. If we're dividing and then taking the log, we can instead take each log and then subtract. Okay, so we have one rule for when we're multiplying two powers of the same base, another for when we're dividing two powers of the same base. We have one more rule of exponents for when we take a power of a power. So let's introduce a new symbol, say p. If we take x to the power p, that's b to the m to the p. And the power of a power rule says that's b to the m times p. In log terms, the log base b of x to the p is m times p, or in other words, the log base b of x to the p is p times the log base b of x. Notice I wrote the p in front of the log just because that makes it easier to read. In words we say the log turns powers into multiplication, or we can say we can use the log to get p out of the exponent. If we're taking a log of a power, we can instead multiply by the exponent and then take the log. So we have the following what we call log rules. And these are just rewrites of our usual rules for exponents in terms of logarithms. The log of the product is the sum of the logs. The log of the quotient is the difference of the logs. And the log of a power is the power times the log. We will use these log rules in two different ways. We'll use the log rules to split up expressions that are inside a log, and we'll use the log rules to combine expressions into a single log. So we will use the log rules in this direction, and we'll also use them in this direction. And that's what we'll see in the next two videos.